Hello everyone, and I hope you're having a good day today, whether you're looking at this on Monday or whether you're looking at it on Tuesday. Just a heads up, we're going to have a quiz tomorrow. The quiz tomorrow will cover adding, subtracting, and multiplying and dividing rational expressions. It will not cover what we're doing today. Today, with solving rational equations, we'll be including that in with graphing rational equations too. Potentially. I don't know. We'll see here, because graphing rational equations can be pretty complex too. So we'll see, but I'm hoping to, yeah. So this topic today will definitely not be on tomorrow's quiz, though. Okay, so anyway, by the way, note about tomorrow's quiz. Tomorrow's quiz, you will have 2 shots at taking it. So you will take it once. If you are satisfied with the grade, then you can stop. If you are unsatisfied with the grade, you may retake the quiz. After your first submission, you will see your grade, but you will not see what you got right or wrong. So I would strongly encourage you, while you're taking the quiz, to think about in your head, do I feel confident on this one? Do I not feel confident on this one? And then when you see your grade, review the questions you didn't feel so confident about, and then retake it. Okay. So for the quiz, you may of course use notes or your homework or anything like that. But in your calculator too, I ask again, you just do not ask anybody else for help. That includes talking to people between your 2 submissions. I would really like you to just work, just for yourself between those 2 submissions to try and improve your grade. Okay. Again, speaking of grades, remember that there is a new, situation for term 4. It's too much for me to go into it in a single video. I waste all my time talking about that. I would suggest you look through it and read through those, things, so that way you can, understand what options you have available to you. All right. And if you have any questions, you can feel free to email me or message me on Schoology. Let's get into things, though. So solving rational equations. So what makes this thing right here a rational equation? Well, it's got a rational expression and an equal sign. So therefore, equation, right? Because we're equal to something. So there's 3 options here that we're going to talk about. I'm going to focus, so the first one is just what I've always told you guys you can solve equations with. You can graph the left-hand side of the equation. So put that in your y1, put that in your y2, graph them both, find the points of intersection. The x-coordinates for those points of intersection, that will be your solution. Okay. To type this in your calculator, you're going to go like in parentheses x divided by in parentheses x minus 3. Okay. I would always encourage you to put parentheses around your numerator and parentheses around your denominator so you don't make any errors. Okay. And so your calculator reads what you want it to read. 99% of the, or a lot of the times, if people make mistakes with their graphs, it's because they didn't put parentheses around the numerator and around the denominator. Okay, and of course your other thing would be y2 equals 2, and you just graph it and find the points of intersection. Okay, we're not going to do that though. We're going to talk about these 2 different strategies here, but we're going to focus on option 3 as our main bread and butter, and you'll kind of see why here in the next problem. But for this one right here, you can see that we have a fraction equal to 2, right? How do you solve this, right? We have variables in the numerator and the denominator here. Well, think about 2 as a fraction itself, right? 2 is the fraction 2 over 1, right? And when you have a fraction equal to a fraction like this, that's called a proportion, right? And we can solve proportions by cross multiplying. So this just becomes x, and then the 2 times the x minus 3 becomes 2x minus 6, and you can just solve here. So I can subtract it, or actually I'll add the 6 over and subtract the x over. So it gets 6 equals x. Okay, just like that. So x is 6. Okay, if you don't believe me, you can try plugging the 6 back in for the x here and for the x here, and you'll get, 6 over 3, which implies to just 2. And so 6 is our answer. Pretty easy. An alternative way to solve this, though, is to find the least common denominator for the entire equation and then multiply both sides by the LCD, or least common denominator, and solve from there. So what would the least common denominator be? Well, again, we have 2 denominators here. In fact, let me try to erase some of these arrows away. We have 2 denominators here, x minus 3 and 1. So this denominator, right, it has a 1 in front of it. We can just put a 1 there and think of it being there, right? This denominator, what is it missing? It is missing an x minus 3, right? This one has an x minus 3. This one does not. Okay, so what's our LCD? The LCD here, the least common denominator, is x minus 3. That's what we would need on both, or that's what our common denominator would be if we multiply this all out. So what am I going to do? Well, I'm going to multiply both sides by that common denominator. And again, it's in an equation, right? So if I do the same thing to both sides, it'll still be equal. Now, what will the results be? Well, the x minus 3's will cancel. And so what do I have just over here? X. Okay, and then the 1 doesn't really have anything to cancel with, so it's just going to stay at 1, so it's 2, and the 2 will distribute. Okay, like so. And then again, you just solve like we normally did. Add the 6 over, subtract this x over here, and so we get x is 6 as well. Okay, let me show you here though, and I'll do it again both different ways. So here's our next equation right here. Two rationals equal to each other. Ooh, no. Okay, and so it moved on me. There we go. So what we're going to do is solve this. Now I already did the cross multiplying right here. So this is cross multiplying, right? Because we already had two fractions. Okay, so x minus 5 times that, 2x minus 10 times that. And you can see that right here. Okay, multiply it out like you normally would, you know, so you get this quadratic here, you get this quadratic right here too. Okay, now we have a quadratic equal to a quadratic. How do we solve quadratic equations? Well, we could use quadratic formula, we could try factoring, we could, you know, complete the square if we really wanted to here. So let's make this equal to 0 and see if we can get it to factor, because factoring is pretty, you know, hopefully pretty straightforward. And this is why we did quadratics before this unit, because we need solving quadratic equations and solving polynomial equation strategies here to help us, right? So subtract, you know, 5x squared over, add the 8x over, add the 85 over, and let's see what we get. We get that x squared minus 8x plus 15. And this, in fact, does factor to be x minus 3 times x minus 5. And so then we get the solutions of x equals 3 and x equals 5. However, notice our denominators from the original problem here. What is an excluded x value? X cannot be 5. So this answer right here, we have to throw it out. Okay, and in fact, we would call this an extraneous solution. Okay, because it's not part of our original domain. X equals negative 5, or x cannot be 5 because it's excluded from the domain there. It would make us undefined. But Mr. Widmeyer, if the left-hand side and the right-hand side are both undefined, doesn't that mean they're equal because undefined is equal to undefined? Yes, they're the same word, but no, we can't say they're equal because undefined kind of like trumps the idea that, you know, they are in fact the same thing. Okay, but 3 does work. You can plug it in and check it for yourself if you want to. Okay, but let's try this common denominator, the LCD strategy that we talked about earlier, right? This one up here in green, all right? Because that's going to be really the better strategy here, and you'll see why in a second. All right, so again, what would our common denominator be here? Well, I rewrote the problem right here, okay, but you can see I took that 2x minus 10 and I factored it to be the 2 times x minus 5. So what's our LCD going to be here? Least common denominator, right? Imagine if you were trying to add these two fractions together, okay, what would be the smallest common denominator that we would need? Well, what's this denominator missing? It's missing a 2, right? What's this denominator missing? Well, nothing. It has the 2 and the x minus 5 for both terms there. Okay, so our LCD is going to be 2 times x minus 5. That will be the least common denominator. Okay, so we'll multiply this side by 2 times x minus 5, and we'll multiply this side by 2 times x minus 5. In doing so, notice what happens. Our denominators cancel here, right? See? And the denominator cancels here. So we kind of are allowed to clear or eliminate the denominator. This is sometimes what the strategy is called, clearing the denominator or eliminating the denominator. And so we can take this 2 that's left over here and distribute it to both terms, making a 6x plus a 14. And then there's a 1 right here, so it's just 5x plus 17. And so then we subtract the 5x over, we get x, subtract that 14 over, we get 3, and oh my gosh, it's the same answer, but a lot faster because we didn't have to deal with quadratics there, okay? So that's the one kind of like bad thing about cross-multiplying is that you can get some really big, you know, polynomials because you're multiplying things together like that, whereas the least common denominator helps to kind of eliminate that. Okay, so consider that. Let's take a look at one more here. Okay, and in fact, we're just going to use that LCD, least common denominator strategy here. So let's take a look at what we got. So I can see 3 denominators here. So I need to find the least common denominator for all 3 simultaneously. Well, both of these already have an x minus 7. So this one right here is missing an x minus 7. So the LCD is going to have an x minus 7 in it. But you can see also that this denominator has a 2. So we're also going to need a 2 in our common denominator as well for it to match. Oop. Oh boy, I'm freaking out here. There we go. So we need a 2. Okay, so we're going to multiply this times 2x minus 7, this denominator, or this fraction times 2x minus 7, and this times 2x minus 7. Okay, remember what we're really doing here is multiplying both sides by the quantity 2x, 2 parenthesis, x minus 7, right? So both sides, left and right hand side, it would distribute to both terms here. So that's why I was able to kind of like write it out the way I had it. Okay, so this will also be a 2x minus 7 there after the distribution. And now we simplify. So the x minus 7s will cancel. We're leaving this 2 to distribute to both terms there. So we'll have 4x minus 18. And then the 2's cancel, so we have this x to distribute to the x and the minus 7. So x squared minus 7x. And then the x minus 7's cancel. 2 times 5 is 10. And so we just, rewrite x squared. Let's see, 4 minus 7 is negative 3x. And then bring that 10 over, it'll be minus 28 equals 0. This does factor to x minus 7 and x plus 4. And so x is 7 will be a solution, x equals negative 4 is a solution. But which one do we throw out? We throw out the 7. It's extraneous, again, because that x minus 7, x cannot be 7 because of that denominator there, or this denominator here, either one. Okay, so only x equals negative 4 is the solution. All right, hope that helps, guys. I'll go ahead and give you guys your assignment. It'll be posted on Schoology there, just a couple practice problems like this. So hope you have a good day. Remember, quiz tomorrow. It will not cover this. It will only cover adding, subtracting, multiplying, and dividing rational expressions. If you want to review, I won't have a review for you specifically per se. I would just say go back and look at your homework questions. Make sure you understand how to do that. And of course, you can always email me or message me if you have any questions. Thanks, guys, and take care.